Hello developers, let's start developing. So, my name is Veko and today we're taking out the last task of this year's Advent of Code. I only have 33 stars so far, so we will need to get some more in order to do that because traditionally this task only has a single part, but the second part, which is the grand finale, it's not a puzzle per se, but it's just a task that only works if you have the other 49 star and it gives you the 50th one. Let's see if it's the same case this year. So, we went through a lot of time and space to find the chief historian, and it seems that he's actually might be in his office. We know that there's somebody in his office. We just have a virtual 5-pin lock that we need to somehow open. We have a lot of locks, a lot of keys, and we need to figure them out. And these are the schematics of our locks and keys. So the locks are schematics that have the top row filled, the bottom row empty, the other way around, that's the key. So this means this is a lock, this is a lock, this is a key, this is a key, this is a key. So we have 2 locks and 3 keys. And they are basically drawn as they are. So we will need to kind of transform them. So let's start with that. So first of all, we will need to read our input, and reading the input is gonna be a bit on the complicated side because you see how this is. So our input will basically be an array of locks or keys, and each lock or key is basically a array of arrays since it's a matrix. So let's see this. This is a simple character matrix. So this is a string array, but since we have an array of them, we will have this like this. So 3 things, 3-dimensional. Great. So let's start doing that. We have all the lines. So first of all, we can take the lines until there's an empty line. So let's have, that's an empty array. And we can also have the characters, which are basically lines that are split that way. And how do we do this so it doesn't break in the easiest way? So we're gonna need to have some kind of a while loop. Or we already did something like this. So we're gonna have let line. We're gonna process a line on a line by line basis, and there is gonna be a line. So while the line is, I'm gonna abuse JavaScript this time. So if the line is truthy, note that this line is truthy, but this line is falsy. And also the line after 39, the 40th line, it's also falsy because it doesn't exist, so it's gonna be undefined. So while line is truthy, we're gonna make a lock or key, something like that, because we need to have code that basically processes this. And I want it to be nice. So how do we do that? So while the line is truthy, let's take the row, and that is, we're gonna split on spaces. We don't need to map on everything. So let's have the result. That's an empty array, but this is an array of string matrices. So over here, we're gonna need to check. Yeah, we're gonna have a bit of nested looping. This is gonna be a string matrix, and we're gonna have a row that we're gonna do it to split, and we're gonna push our row to the matrix, since the row is actually an array of strings. Yeah, that works. But we will want to loop this while the line is truthy. So we are pushing that, and then we're gonna push the matrix at the result. So we're gonna, line is a string, so if string with the length 0 is false. So we are moving along, so we have an empty line, we're gonna push the matrix, and we're just once more gonna shift the line. We don't actually need this exclamation mark because we're checking for that. So at the last line, we're gonna shift once more, hopefully skipping that, and we're returning the result at the very end. It might work, it might not. One way to find out. So for each matrix of the input, well, print matrix, that matrix, and then we're gonna add a dash. Let's see if we get something, not a get status, but npm start 25. This is the last one. We got 1, 2, 3, 4, 5 items, and let's see if they are the ones that were put in. Looks like that. The second one looks like that. The third one as well. The fourth one and the fifth one. So it seems that we read them correctly. So now, first of all, what we want to do is we're gonna want to map them. We either map them to a key or a lock. So let's say we have a type for that. How do we call something that's either a key or a lock other than the type key or lock? Every lock and every key. Lock opens the key. Let's call it lock key. Why not? We're gonna have a type which will either be a lock or a key, and we will have the values, which will actually be an array of number. Because now we need to basically read this image. You see, this image is a lock that has the pin heights of 0 after the first row. The first row doesn't count. 1, 2, 3, 4, 5, 3, 4, 3. So this is a 0, 5, 3, 4, 3 lock. 0, 5, 3, 4, 3 lock. And the total height of everything, I think it's 1, 2, 3, 4, 5, 6. Or is it? No, the first one row doesn't count, the last row doesn't count. So the whole height of this look is exactly that. And I think that we're gonna need that as well. And let's have the height as well. Or is the height constant? So let's just do this for of matrix or log key. Actually, let's call it matrix of the input. Let's just console log the no, we can just do the matrix dot length because this is the yeah, why not both? This is the dimension of the lock and key. I just want to make sure we don't really need this for solving this, but it is an assumption that I'm gonna make. So we basically have a 5 by 5 block because the top and the last row doesn't really count. Let's check the big input, whether we have the same thing as well. Because it is kinda implied in the description, but let's check it. Yeah, we're guaranteed 5 tumblers. All of these is 7 and 5, so we can just assume that all of the locks and keys have the exact same format. So, which we can actually, we don't need to hard code it, we can calculate it. So, the height of the locks and keys is that minus 2, the first one and the last one row doesn't count, and the width is actually the length. So, now we can just loop through them. Oh, nope. This is the length of the first item. Yeah, because input of 0 is the matrix. So this is matrix of 0 dot length minus 2. Or is it? This is the height, so no. We have it like this. Let's just console log this because if we're supposed to get 5 and 5, let's verify that we're getting 5 and 5, 5 and 5. So our logic is, let's say, sound for now. And one thing that annoys me, especially with junior developers, they never do this. They never actually check whether some code they wrote is immediately correct. Because this is code that I wrote literally 5 seconds ago. If I have an error, I can reason about the error. I'm not going to get it after I write a whole lot of code that nobody understands. So for each matrix of the input, what do we want to do now? We want to separate the locks from the keys. So for each of the matrix, if we can only check this corner or this corner, and we actually need to only check this corner, because if this is a dot, that's a key. If this is a hash, that's a lock. So let's say we can say actually the type of the lock key. We're gonna take the corner of the matrix, and if that is a dot, then we have a key, otherwise we have a lock. Okay, and now we need to get the heights. To get the heights, we will not height plus 1. Let's just do this because I want to see that we're getting a 5 by 5 matrix. Not for the big input, we basically wanted for the small input as small as possible, and we want to lock the type and print the console. So we should get 2 locks and 3 keys. So that's a lock, and it's 1, 2, 3, 4, 5 by 5. That's a lock, that's a key, that's a key, that's a key. So now we need to replace this log. How many hashes we have here? 0. How many hashes we have here? 5, 3, 4, 5. We don't really care if they are in adjacent rows because they will be. But we already know that, so we're not gonna check for that. So what we're gonna need to do? We're gonna need to take this and reduce it. So I'm just gonna use that, and first of all I'm gonna add an array that has the width items, and I will fill it with zeros. So I will initialize the reduce with basically 0, 0, 0, 0, 0. And then as each rows comes along, I will say, this is totally incorrect by the way, so the previous thingy is come on, it's not, this is a string array, so the previous, the current, this should be an array of numbers, and the current it will be an array of strings. So for each of the current we will need to join the previous with the current. Let's just do it this way if we want to, for now. So we can literally loop through the previous and say previous of, sorry. If the current element of index is a hash, previous of index gets increased by 1. And then we return the previous. Or we can actually say something like this. Take the previous and map it. And we will get the value and the index, and we will return what for that. So if the current of that index is a hash, then we're gonna return value plus 1, otherwise we're gonna return you value. So this looks more complicated. By a bit, but it is kinda slower. Anyway, what I want to do and what this should return, come on, it's not any. It's a number array. Yeah. And that should be the values. Let's just log the values and see what, let's log the type and the values. This is an array of log keys. So we're just gonna push this to the log keys, and now I will just say for of lk of log keys. We will just log them and see what happens. So we should get 2 logs and 3 keys. Let's see if we are correct on the values. So we have 05343. Yep. First key has 50213. Yep. And then we have log 12053 and key 43402 and key 30201. Yep. So whatever we need to do, we need to separate them. I didn't want to separate them initially. Actually, why not? We're gonna have logs and we're gonna have keys. So we're not gonna do that, and we can just say if type is log, push it to the log, otherwise the type is key, push it to the keys. So because what are we gonna do now? We're gonna need to check everything with everything. And this part is gonna be quite easy to do. I mean, as programmers, we often have trouble when we have to check some kind of a constraint value so that we don't check everything with everything, but this time the algorithm actually says check everything with everything. That's for each key of keys, for each log of logs, check whether they fit. And how do we check whether they fit? Well, we need to see if they have an overlap. An overlap means that a key would hit the lock. So this lock has three. The prong on this is three items long, and the prong on the key is also three things high. Three things high. So which means that on this position they overlap. Both the key and the lock have a thingy, so they won't work. So now want to see whether they fit together. How do we do that? Well, we're gonna add them up. We don't have a zip method, but we can just say, yeah, we can say key.map, value and the index. We're gonna get the key and try to push it into the lock because we're gonna get the value, we're gonna get the index, and now we're gonna get the appropriate lock thingy. We're not gonna see the key is a lock key. Yeah, so we need to take the values and we need to map them. So we're gonna take the appropriate thing from the lock values and we're gonna add it to the value which is from the key. Yeah, and we're gonna get a set of those and we're gonna ask, is some of those values bigger than the height? So all of this will just return a true or a false because we're taking the key and for each item of the keys we're adding the appropriate value of the lock. We're gonna get something. Yes, let's leave this for next. Const, this is the match and let's just console log key log match. So we have two logs, three keys, which means we will have 6 pairs. Let's check that. 6 pairs, and those are the pairs that we have, and we have the matches, and you can see some of the matches has 6s, some of them don't, which means that do we have the same thing? Oh, yeah, let's change it so it's better matched to whatever the input is. So we're just gonna take this part and put it here because we're writing the log first and then the key. So we're taking the log and methodically trying all the keys. So this will be similar to that. Yep. So we have an overlap in the last column, damn, overlap in the second column. Yep. All columns fit, no 6s, all columns fit. No, this is an overlap on the first column. It fits, it fits. Yeah. So now we can say whether one of these is bigger than the height, and the height is 5. So we will add that sum where the value is bigger than the height. So now instead of an array, we will just get a true or a false. And we want it the other way around. So we don't want some of them to be bigger than the height. We want every of them to be less or equal. Yep. So we want every of them. And Yeah, every is a bit slower than some because some can totally. Yeah, it's about the same because some can return true uh, earlier because the first one that is true, some can return true. But on the other hand, every can return false earlier because on the first one that is false, it can return. So anyway, we're gonna need to check something like that, but it's only 5 items and it's gonna be reasonably fast. And we got the three lock key pairs that fit together without overlapping. So instead of doing that, we're just gonna have a counter here, and we're gonna increase the counter if we have a match. Of course, we will return the counter, and we should get just 3. The result part 1 is 3. I will remove part 2 out of this for now, so we don't need to run it since we only have one part. And let's once more take the big input and try it on for size, whether we get an answer that actually makes sense. 4,000 rows, let's run them, and we get that we have 2,600 combinations that we need to try. Hopefully we will get to the chief historian in time. That is the right answer. Let's see what part 2 says. Usually that is the checked off that place with a star with all the time to finish the chronicle. Oh, the chief historian was actually sleeping while doing a lot of chronicling. So we need to put a star on each part of the chronicle, which means we need 15 more stars. But this actually means that we solved day 25, the only part that is solvable, and now we need to go back to the calendar and fix all of this. All of this needs to be 2 stars. We already discussed some of the solutions that we will need to implement, but this is the last day that we're gonna have a daily video because I want to finish it. I want to get to the grand finale and press a button and have this light up, and it will. But we will do this maybe at a reduced cadence since the New Year's is coming and the Christmas vacation is coming and so on. So anyway, happy Christmas. Don't forget to click like and subscribe and keep developing.